All right, so I'm pleased to introduce you to this session, which is all about unlocking advanced search capabilities with Milvus 2.4. Our guest speaker, James, which is the VP of Engineering at Zilliz. James has extensive experience as a database engineer at Oracle, Hedvig, and Alibaba Cloud. James also played a crucial role in developing Hatchbase, Alibaba's cloud's open source database, and Linform, a self-developed NoSQL database. He's also a respected member of the Technical Advisory Committee of the Linux Foundation, AI and Data Foundation, where he's contributing his expertise to shaping the future of AI and data technologies. Welcome, James. The stage is yours.
Hi, Stephen. Yeah, hi everyone. So James here, located at the San Francisco Bay Area, working in Milvus for the last 3 years. So currently the chief architect for the Milvus project, also a maintainer. So yeah, glad to talk to you guys. And if you have any questions about Milvus 2.4, we can discuss in this session. Cool. Stephen?
Yes. Do you want to go and share your screen now, James? So you can go over
Sure,
the different releases.
So, yeah, I actually have one short deck. Yeah, but we have some like highlights for Milvus 2.4. So, so you want me to do the introduce or?
Yeah, if you want, you can either go directly over the highlights.
Yeah. So, we recently just released Milvus 2.4 release candidate. It's not a final version yet, but hopefully the GE version will be come out next week. So this is actually a long version compared to Milvus 2.3. We spent around like 6 months working on all this stuff. I think the major change is that we support multi-vectors and also hybrid search inside Milvus, because before Milvus 2.4, each of the roles or each of the entities can only support one vectors, and Euro is going to be a dense embedding. Once multimodality and RAG application becomes so popular, we soon find that users are actually looking for like a better way to describe their data. It's not only be one vector, it's probably like based on different embedding models, or maybe just attributes, or just different features for their entities. So we have these multi-vectors. We support a sparse embedding rather than only dense, so you can have better search quality. We support a grouping search, which is a great functionality for RAG applications. We support a inward index on top of or the scalar data. So when you do filterings, it's actually help you to accelerate. We also supported fuzzy search, fuzzy filterings. So you can use regular expressions to do all those filterings. Yeah, and the most exciting feature in 2.4 is definitely GPU index. We worked with the Nvidia team, so they actually offers vector search algorithm on top of Nvidia GPUs. It actually works pretty good, 10 times faster. If you're running on a small batch, you can easily achieve like 50 times QPS throughput increase if you have like large amount of batch, if you're trying to do offline works. So we'll go through all the steps. So those are just some functionalities help you to like better doing AI Gen AI applications. Yeah, so the overall goal for 2.4 is more like focus on Gen AI application use cases. We're trying to help users who want to do RAGs, who want to do all kind of multi-modality search with more semantics, with more search qualities, and also performance. Yeah. Right. So we will go into some maybe details for each of the features. I think the first one will be to be mentioned is that actually multi-vector search and hybrid search. So as I just said, right before that, each of the entities only have one vectors, but under some use cases, right, you have your description for one of your photos, you have your embeddings on one of the pictures, and maybe it's from different angles, right? See what happens here. You have Tesla, you also have the description. And when search happens, it could be either like search by text, it could be text to text, or it could be text to image. Yeah, before that, you have to create multiple collections, and you have to develop your own ranking models. So now what we can do is you can store like multiple embeddings in one row. So when search happens, it will retrieve from both field, and they will do a re-ranking algorithm, help you to find the like top K candidates. Yeah, with this feature, like it's pretty good for multi-modality use cases. Pretty good if, for example, if you're doing RAG, you can put titles in one embedding, maybe abstracting other embedding, so help you to improve the search quality. And the most exciting part to work with multi vectors is that you can have different embedding models. You can use OpenAI together with Cohere. So both of them can find some different materials, and you can retrieve get more interesting candidates. And you can also use dense embeddings plus sparse embeddings. Yeah, and then that what comes out is sparse embedding. Yeah, so before that, most of the embeddings we support is just dense. We also have binary embeddings, which is very popular recently, but most of users just using dense embeddings. When we talk about dense, it usually means that each of the dimension has some value. It's actually a float number. There are no zeros inside, and dense embeddings usually come from machine learning models. It's more for semantics, because when we generate dense embeddings, we also have those contexts. So this is not only about this word, but also about a sentence or about a paragraph, right? But for under many of the use cases, we still want keyword search or still want to focus on the details. That's why usually people do hybrid search between vector DBs plus Elasticsearch plus Solr plus all kinds of other search engines, right? But now we have sparse embeddings. So what sparse embedding does is that first of all, it's sparse, which means most of the dimensions are just going to be zero. Yeah, but why? Is because for sparse embeddings, we actually have a dictionary. So each of the token is actually one dimension. So if you guys are familiar with what birds have, each of the bird is usually around 30K tokens. So which means our sparse embeddings is also around 30K dimensions. It has a much larger dimension compared to dense embeddings. Usually dense embeddings is going to be 768 or 15K 36, right? But for sparse embeddings, you have larger dimensions, but luckily most of the dimension is going to be zero, which means this corpus or this query has nothing to do with that token, right? So by using one weight for each of the token, sparse embedding focus more on details or more on keywords, more on token search, right? So they are trying to find tokens very similar to like between query embeddings and the corpus embeddings, right? So this is extremely helpful if you want to say, let's say I want to search the movie I watched yesterday, right? Under some of the use cases for dense embeddings, you get all the movies not only for yesterday, but you got movies for the day before yesterday or maybe last year, because it's still very close or very similar in the semantics, right? The movie I watched yesterday and the movie I watched the day before yesterday, right? But with sparse embeddings, yesterday becomes keywords, so it actually narrowed down what you want to search. Yeah, that is extremely helpful under many of the RAG use cases where you want to get controlled answer, right? You want to focus on those keywords which are actually delivers key informations, right? And the other good part for sparse embeddings is you can work together with dense embeddings. So sparse embeddings focus on all the details. Dense embeddings focus on help you to get context. And when you search from both embeddings, you retrieve different kind of information and you do rankings. to get the most relevant informations. Yeah. Okay. So third one is actually grouping search. It's also one interesting use cases for when you do reg. Most likely you're going to chunking everything. You put a chunk of the document and you're also embedding the chunks. But the thing is, when you do top 10 queries, it is likely that you get all the chunks from one single document or one single book, which means you lose your diversity, right? You definitely can do more if you have this diversity, and you can do re-ranking. You can show it to your users, so they can pick which of the document or which of the book is actually more relevant. But what happens could be like most relevant thing are just from one book or one document. Yeah. So now we have a new functionality called Groupby. So if in your data model you have one field, it could be document ID, it could be book ID, and when search happens, you can group by this book ID. So we are not returning the top 10 most relevant chunk, but rather than return most relevant document or most relevant books. So the way we do that is it's more like a traditional databases. So we actually iterate through all the most relevant chunks, and we try to group by everything like a relational databases. Yeah. So the output usually has the group ID, which is your document ID in your case, and also like the most relevant chunks in this group.
Yeah, James, I'm just going to stop you here. There's a question quickly from the chat, which
Sure.
is, can we somehow restrict the scope of while querying, like per workspace, client, or group?
Yeah, pardon me, can you
Yes, I'm going to repeat the question. Can we restrict the scope while querying something? Like, can we restrict it per workspace, or per client, or per group?
I'm not sure if I get the question, but I thought what you're actually asking about is multi-tenants, like how if we have multiple tenants in one collection, what will happen to limit my query to only part of my data. Is that correct?
That's what I
Yeah.
assume.
So yeah, if I'm correct, just give me more information. But yeah, so what I'm saying is that you have to use another feature we offered in Milvus 2.3, which is partition key. So with this feature, because I know a lot of reg applications, they're like doing multi-tenancy stuff. So we have multiple users. They definitely don't want to see each other's data. Yeah. So the easiest way is when you create a collection, you have one partition key field. So when search happens, you specify which kind of the partition key. It could be a knowledge base, could be a user ID, could be an agent ID, whatever. Like it has to be like usually you're gonna have more tenants. It's gonna be 1,000 tenants or maybe even 100K tenants. So each of the tenants will be stay in their own partition key, and when search happens, if you specify the partition key, all result will be just related. Yeah.
Cool. Thank you. And there's another one which is related to grouping search. Is grouping search supported with multi-vector?
Yeah, it's actually it's actually supported. So we actually start from supporting density embeddings. We also support sparse embeddings and also binary embeddings. So when it becomes GA, I thought is going to be support all kinds of embeddings.
Cool. Thank you.
All right, so let's keep moving. Yeah, if you have any other questions, I just typing on. Yeah, I'll go through all the questions later. Yeah. All right. So that is what how we're going to use this grouping search. So yeah, you have one collection with data with one AN field. You also have this group by field, which is usually a document ID. When the output comes, you asking for document IDs and also passage IDs, which is kind of like the chunk IDs, right? So the result looks at like below. So it's usually one distance plus one document ID and also one passage ID. So you know which document is actually most relevant and which of the chunk inside this document is actually relevant. Okay. So another interesting use case is actually fuzzy search, fuzzy matchings and inward index. So thanks to the Tentavi community, we now have a very high performance inward index, very similar to Lucene, but is written in Rust. Yeah, so finally, Milvus is also a part of the Rust community. So with the inverted index offers very good filtering performance, as the graph shows on the right side. So if you're trying to filtering on large amount of strings, large amount of integers, inward index definitely help. The only edge case is that when your virtual condition matches like maybe 50% or more of your result, then it doesn't really make sense to use inward index. You should just directly filtering on all the data because inward index usually works good for low cardinalities, right? So another thing brings into Milvus is that since Tentavi has fuzzy search supporting, now we also support not only prefix filterings but also postfix and in filterings. You can use very simple regular expressions to start with some kind of wildcard and to end with the other like wildcard, right? So inward index help to accelerate performance on the fuzzy search. It also pretty important for many of the use cases, especially when you have chunks into the vector DBs. So you pretty much know what is the original contents, and you're just looking for certain keywords. On that time, like the further search and inward index help you to improve the performance. It's not going to be super fast compared to prefix, right? If you have the choice, definitely do prefix, definitely do exact match. But if the data is already there, unless you want to search, then yeah, at least you have one choice. Okay. GPU index. So I know a lot of the users are just asking about what is that going to be beneficial if vector search using GPUs? Before 2.4, the answer is usually no. GPU is actually much faster, but yes, also has a lot of limitations. The cost efficiency is actually not good. GPU is just too expensive, and also if you have very smaller batch, GPU index usually takes a lot of time to copy data between main memory and GPU memory. So it's not a perfect solution, at least not before 2.4. Yeah, so recent 6 months, we've been working very closely to the Nvidia team. They actually have this fancy GPU index called CAGRA. You can also get more information on the yeah, so with this CAGRA index integrated into Milvus, what we find is that if you're trying to do brute force, it's actually 100 times faster. If you're trying to use graph index, it's usually 10 times faster compared to HW. If you're using IVF index, it's usually 30 times faster. And we tested on both AI100 and also L40, which is the latest inference card. We find that the L40 T4, A10, those are like cards very good for vector search on GPUs. Yeah, and under those scenarios, if you have large batch, if you have very high QPS, you want to keep your search latency stable, GPU index might be your choice. You could definitely test on that. Okay, so here's some numbers. So the first one is on the top is actually CPU agent support it's kind of like the sought out for CPU index. Yeah, if you have A10 or if you have you are doing a flat, which means it's 100% accurate on GPU, you can still get very similar performance compared to CPU graph index. And if you're using a GPU to do some AN search, right? Look at the last line, which is the number we got A100 plus CAGRA is like 10 times faster compared to a CPU engine W. Yeah. So that's a trick. If you are looking for high recall, definitely use GPU for flight index. If you're looking for very high performance, stable latency, yeah, definitely pick CAGRA index. Yeah, but there is also like one major drawback is that when you use GPU index, you have to ping everything in your GPU memory. As we may know that GPU memory is actually very expensive. So it's kind of like based on your use cases. I know a lot of guys who is trying to build their recommendation systems. GPU index will be perfect for them, but if you're just doing some rags, maybe not as good because I think for most rag applications, cost efficiency is actually going to be more important compared to like performance. Okay. Yeah. Then it comes to be cost efficiency. Yeah, we have this Nmap solution. So before that, all of your data of your vectors are directly loaded into memories, even if you're using disk index, original data is on disk, but also we have a smaller index in the memory. It takes a lot of storage resource. But under some use cases, if you don't really care about performance, just want to lower your cost, then one of the other choice is that you just mapping everything onto local disk. It's still going to be searchable. It's actually swiping in, swiping out between the operating system page cache and also the disk. It's actually going to be slower compared to HW and the other index. But the thing is, you get four times of your vectors stored in your vector DB with almost no performance decrease, like 10%, 20%. Yeah, but do remember if you only use that map, you have to use very high performance disk. Usually it's going to be NVMe SSDs. You cannot run it on any of your SATA disk. Not even, I'm not sure how EBS is good at it, but we would recommend to use if you're running on AWS or running on the cloud, we definitely want to use IO2 or maybe local SSDs. It's going to be much cheaper compared to memory. Yeah, but and with the high performance disk, you get similar performance, a little bit lower like latency, but it is actually much cheaper. Okay. Yeah, another exciting feature is about change data capture. So when data is written into Milvus, a lot of users are asking for how can I get the data out? Maybe you want to keep the data consistency between two Milvus clusters, one from US, one from Europe. That is one use cases. On some other use cases, user want to do incremental backup. So we have this CDC. So CDC is actually a subscriber for Milvus log. Just like if you guys are very familiar with MySQL bin log or Postgres logs, every databases have their own Red Hat logging. So CDC export this Red Hat logging. It could be deliver those logs into another Milvus cluster, into a Kafka, so it can consume all those logs. And CDC can work together with the backup. So backup has full data, and CDC covers the streaming data or the incremental parts, right? So if you merge all the data together, is going to be all of your data set for both historical and for both streaming, right? So this is going to be widely used on those cloud also. We use this for doing cluster replications. We use this for incremental backups. So we offer these great tools. You might need to have some special implementation on your own use cases. on cloud, we have all those for free. So the easiest way to use CDC is just to use those cloud, but still it's actually open source too under Apache license. So if you want to do any of your tailor your own applications, CDC is a great tool. Yeah, it support all kinds of different operations. They have create job collections, have insertions, deletions, or kinds of the meta operations. So you can just subscribe all those informations. Is and maybe and integrate with other systems. Okay. All right, I'll just stop here. So those I think pretty much for 2.4 features. I have another page for 3.0 roadmaps, but we can stop here and see if you have any other questions.
Thank you, James. Yeah, we have a couple of more questions in the chat, which is again related to the partition keys. So someone is asking if we can specify multiple partition keys in one query.
Yeah, each collection can only support one partition key. That is the current limitations, but you can also use filterings. I think the best practice is that if you're trying to do multi-tenant use cases, you use one partition keys, which is usually you almost going to create everything based on this partition keys. A best practice is tenant ID, knowledge base, those kind of informations. And under that, if you have any other like expressions or conditions, then you can just use filterings. You can have like multiple different field. Some of the field maybe let's see if you're trying to build a book reg systems, you may have author field, right? You may have also like pages, right, as meta information, right? So when the search happens, you can just specify expression, page equal to 1, author is J.K. Rowling, those kind of stuff. Yeah.
Cool, thank you. And going back to the fuzzy matching and inverted index slide, can you go over what brute force means? We had, there's a graph of about inverted index performance, and it's written brute force here. Can you go over it, please?
Yeah. So we want to filtering on some of the conditions. So the easiest way to do is brute force search. So what we do is we just get each of the integers. Let's say if integers field, so we just get one of the integers doing the comparison based on what kind of expressions you have. Maybe it's just a equals to 1. So we get row 1 of this field with field A, compare it to if it's equal to 1. If it is, then the filter pass, right? Other than that, we go to the second row. So we finish all the rows. That is what brute force are doing. Yeah, the only is not that easy because we highly depends on SIMD instructions. So most likely what we do is we'll compare 8 different flow numbers in the same time. So it actually improve the performance. Yeah, but when you have inverted index, things are like very different because we change the order of every data. So we put all the data with A equals to 1 together. So when you ask for A equals to 1, we don't really need to compute it through everything. We just need to get all the data with A equals to 1 and put it into a bit set. So it's actually much faster because we change the data layout.
Cool, thank you. Thank you. We still have more questions. Oh yeah, one. Which of these features are available in Zilliz Cloud as of now? And if they are not, when would they be?
That is a good question. What we do right now is that Zilliz Cloud is usually going to be 2 or 3 months later compared to open source. The reason is for open source, I know there are a lot of users who want to use new functionalities because they are still under their POC stage. They don't although stability is going to be very important, but even many of the users are using it into their test environment, even it's not stable enough, it's still a release candidate. Yeah. So we try to release everything as soon as possible. But for Zilliz Cloud, we want to keep things stable enterprise ready. Yeah, we want to give you the best practice, not to be something like not we are very comfortable with. So usually it takes another 2 or 3 months before we put everything to the Discord. Yeah, we try to beta those functionalities early May. Yeah, you have your choice whether you want to upgrade or not, but to put every cluster into 2.4, maybe see you another 3 months. Yes.
Cool, thank you. Someone asked, is there a partition size limit?
Oh, okay.
Or
So
something different?
I thought this is another multi-tenant use cases. So to do multi-tenants, you actually have 2 or 3 different ways. One is using multiple collections. One is using partitions. Those are actually going to be very similar. So my suggestion would be, if your tenants number is definitely less than 1,000, maybe a little bit more than 1,000, then use collections to do the isolations. That is usually under some use cases for SaaS companies, when they want to build some product to business or to enterprise users, you won't have 100K enterprise users, right? Then you're definitely going to be a big success. But under most use cases, you just have 1,000 enterprise users. You can just isolate each of the users by their by collections, right? So then, but still have a limitation. I don't think Mills can do more than 10K. I would say keep the collection numbers smaller than 5K. We actually did a lot of enhancement on that for Mills 2.4, so it should be much better for compared to 2.3, but still a lot of limitations here, right? But if you try to build something that for consumer applications, then you have like large number of users. It's going to be 1 million users per day. Then you definitely cannot use collections to isolate or partitions to isolate all the data. Then that's why we have partition key. It helps you to isolate smaller tenants in one large collection.
Thank you.
Yeah.
We do have more questions coming. So there's one that is, can the group search handle offset and limit parameters with respect to its outputs for pagination?
Yeah, so they still have offset and limits. So, but the semantic is a little bit different. So, when you use offset, you actually offset art documents rather than offset chunks. So if you offset 10, if offset equal to 10, which means I want to find all the documents or the group with inside the like 10 to 20 groups, not like 10 to 20 documents, not 10 to 20 chunks. That is the major difference. But yes, we support.
Thank you. There's one which is related to the GPU release, which is there a way to configure index so that indexing of new segments will be on GPUs, but querying of already indexed segment will be on CPUs? Is that possible?
That is a good question. So the answer is we're actually working on that. So far, no, because for CAGRA index, it is actually a special graph. So it has to be searched. We try to search on CPUs, but the performance is really bad because GPUs doesn't really care about computation powers. So what they do is try to use more computations so you can get higher qualities. Yeah, but if you use the CPUs, then computation powers become the bottleneck. So you cannot really use the same graph architecture. Yeah. So, but what we do is we try to adapt CPU index into GPU, let GPU to build it. We have some progress on it, but it's not released yet. Yeah. Let's wait. Maybe 3.0 we get all those stuffs.
Cool. Thank you. Another question which is related to scoring metrics that are supported for hybrid search. Are we supporting them all, like IP, cosine, L2, or are those limited?
Yeah, that's a good question. So we actually support them all. One of the easy way to do re-ranking is using RF. So it's just based on rankings. There's nothing to do with the distance, how large the distance is. We also have support another mode called the weighted score. under that case is what we do is we do a normalization of the metrics. Usually cosine metrics is between 0 to 1 when you're using IP metrics or when you're using the other kind of metrics like Hamming metrics for binary or L2 metrics. Then we actually do a normalization to make sure that the distance between 0, -1 and 1. Then you can assign weighted between different metrics. Yeah, so that is really what going to be work. But yeah, well, I would recommend if they can be in the same metrics, that'll be much better.
Thank you. And also, someone asked, so we have Milvus as a backup as an option for backup. Sorry, do we have plans to integrate with storage vendors like NetApp to leverage like their snapshot technology or anything?
Not for now. Yeah, so any of the like storage vendors will be very open. Like if they can offer some help, yeah. So we can integrate all the storage, but for now, Mio is more focused on the cloud. So what we do is we usually would just be more focused on object storage because it's works like the common protocol on the cloud. We actually supported EFS, which is the file systems on the AWS also. I thought it's going to be very little work if you want to use any kind of the file systems, NAS, EFS, yeah, offered by the other vendors. As long as it's just for backups. If you're trying to use it to do search, most of the remote file systems is not like performant enough. So yeah, but backups should be very easy.
Cool. Thank you. And someone asked, in the example of the group search you have on the slide, why is there only 6 grouping results when the limit is set to 10?
Oh, it's just because I don't have enough room. Yeah, so ideally you just have 10 results, yes, but I just have enough room on my side, so just cut off. Yeah.
Thank you. And I think that's the last one I have, at least for now. Does Milvus support querying data on one or more multi-dimensional data cubes at the same time?
I'm not sure what is the
That's
data cube.
that's what I was
Any
looking.
point?
It's like multi-dimensional
Yeah.
arrays, multi-dimensional array of values. Sorry.
I'm not sure if I get the questions correct. So if you're trying to do something as a geospatial search, uh, yes, it's actually in our plan. It's not yet. For very small dimensional data, maybe 2 dimensions, 3 dimensions. No, we actually work with some other engineering team in the big company. So they actually have a lot of geolocation applications. So what we want to add in 3.0 is we want to have a geolocation that has also daytimes. So when search happens, you can also like limit to a location. That'll be good enough. That we are very good for if you are trying to build some location aware applications like delivery systems, like something like Uber, something like yeah, DoorDash, those kind of stuff. Yeah.
Thank you. I don't have any more questions so far. I'm just gonna wait a quick minute.
Yeah, and maybe I can just quickly do what do we have for the 3.0,
Go for it, yeah.
right?
Thank you.
Yeah. Okay. Oh, give me one moment. All right. So here is something on our roadmap for 3.0. Is not a final decision yet. So if you guys have any other like suggestions, if you have any feature requests, we'll definitely want to talk to you guys. Send me emails or directly go to the GitHub. We definitely still waiting for more suggestions, right? I think 3.0 is actually the biggest release this year. It's gonna be happening maybe July, late July or August. So there are a couple of things we want to do, not only for reg application users, but also for like more interesting use cases. One is definitely scalability and performance. You may know that the Milvus is very good at scale, but we still want to lower your cost under many of the use cases. We see like users have 10 billion vectors. It's actually cost them very large cluster, like 1,000 cores. So it's going to be very expensive, but under some of the use cases, the search really happens. That's why we have this little load and also autoscaler. So when little load happens, you don't really need to like load everything into your main memory or your local disk. Every data stores in object storage. When search happens, we load everything and cache it into your local disk. So it can be lower your latency. The latency will going to be increased, lower your throughput. But then you definitely store more data on one node compared to previous versions. And you can use autoscalers. So we don't have if you don't have too much requests, then it help you to like scale down. Yeah. Performance, we're still working on GPU accelerations. We really want to add more the current functionalities, including grouping search. So far, GPU don't have load support for very advanced features. So we really want to have all the features support on GPU index. And second thing is doing more quantizations. We're going to support binary quantizations because it's very popular, and many of the embedding vendors already supporting binary quantizations. Yeah, we have our new storage on S3. So newer storage on S3 actually accelerate point queries. It actually helps a lot when you want to specify output fields. You want to get the data out of vector DBs rather than only scores, right? So the new storage is actually optimized for point queries, and it's also optimized for object storage. So it should be greatly improve the performance if you doing reg applications, you want the chunks out, you want some of the meta information out. Yeah. We also worked a lot of things on the ease of use. We have a Milvus local mode. It's actually a new mode for data scientists. For Milvus, I think the deployment is actually too complicated for a lot of users, especially when they want to first-day users, they just want to test. Now what we can do is we can just do a pipe install to install Milvus in just maybe 1 minute. It has exactly the same APIs, but not support full functionalities, but it's pretty good for day one users. Yeah. We also try to integrate the Milvus local mode together with LangChain, together with Llama Index. So it's good enough for you to do a lot of experiment under like 1 minute data set. Yeah. We have new SDKs. Rust is actually our top one priority. We saw a lot of Gen AI users trying to use Rust. And yes, we're going to officially support Rust SDKs. C# come from Microsoft. Their team did a great job to follow up all the new functionalities. Yeah. We'll support more database operations like schema change. Sometimes when you're trying to build applications, at the day one, don't know what kind of information it's going to have. Definitely you can use dynamic schema, but the filtering performance is actually lower. So you can use schema change, add one column or delete one column. Yeah. We're going to support more data types and more index. One big thing we want to do is index on JSONs and on arrays. We're also going to thinking of supporting daytime data type and also geolocation data types. Yeah, to support geospatial search and also a lot of use cases for agent, you really want to filtering based on time, then daytime is actually the data what they're looking for. Yeah, we're going to support primary key deduplication, because now we keep telling all the users you should design your primary key, make sure it's unique. But still, under some use cases, what happens is that, for example, your Kafka crash, you have to wait and retry. When your retry happens, actually there two entities with same primary key. That happens, right? So we'll help you to protect. So that will be happens on 3.0. We have actually another Kiwi storage help you to maintain all the primary keys. So when this primary key is already in, we directly throw an exception out, or just use, if you follow in-damped designs, we just ignore those duplicated primary keys. Yeah. And the other most exciting part for me is that 3.0 is actually going to add more model stuffs. So before 3.0, when we very focused on build these infras, yeah, we actually did a good job on that, but a lot of users just asking where I'm not a expert on embedding, re-ranking, everything is just too complicated for me. Is there a way I can do a data in, data out, rather than I generate all the embeddings and send to the VectorDB? Yeah. So 3.0, we are going to work with a lot of inference vendors like like BentoML, like a lot of model providers like OpenAI. So what we do is we actually have a function. So you can just give us chunks, and we'll just calling a function, and the function actually integrated with all the other embedding providers and ranking, re-ranking providers. Yeah, so then Milvus have all the original raw data. Embedding happens on their side, so we just help you to call in their reference like inference engines, right? So we also support more semantic search use cases. Now I think most users just using AN in Milvus, but we actually want to add more different semantics. We want to add the NN filtering, nearest neighbor filterings. So the filtering not only happens on scalar data, it also happens on vectors. Let's see if I have a bunch of dog photos and also some cat photos. The search might be, I want to find all the similar dogs, but definitely not cats. So you give one positive example as a dog. You can also give them one negative example as a cat. So we just try to get most close result to dogs, but try to filter out cats. Multi-target is kind of like a similar use cases. So when you start search, you probably don't know what kind of stuff you actually search with. So you give one positive example, we give you like 100 similar result, and from those results, some of them might be what you really want, the others might not. So you can mark the things you want as positives, and things you don't want as negatives. And you can do another search. Then it's called multi-target search, because it's not only one query vector. So you have multiple positive examples and multiple negative examples. Yeah, Milvus try to search based on all the examples, try to get closer to the positive embeddings, and get far away from the negative embeddings. That could be extremely helpful if you try to discover your data, so you have like exact targets. Yeah, it's pretty much for 3.0.
And that's for this summer, right? The hope is to release it around summer, right? And James? The hope is to release 3.0 for
that's
summer,
for
right?
this summer.
Cool.
Yeah, that's where we're targeting July. Sometimes we actually delay it because we're just trying to add too much things into one release, but we are trying to deliver in time. Yeah.
Okay. Okay, cool. Thank you. We have one last question, and then I think that should be it for the webinar. Does Milvus support changing fields and not vector fields? So like if you have a value that is already inserted, one possibility is to do upsets, but then the person is also asking, will that trigger a reindexing of the vector field?
Yeah, that's actually a good one. I'm thinking of this. This is also heavily depends on the storage format, because to mutate everything your storage format, because Milvus is a little different from other competitors. We are like a distributed storage and computation. So you definitely get the benefit is the systems become very elastic and also easy to scale. The problem is you cannot doing any modifications on top of object storage, right? So you have to carefully design the storage format before we can support update or change the fuse. Yeah, but for sure, yeah, we are thinking about this probably not in 3.0, maybe in 3.1 once we have the new storage format that makes us easier to do that. Yeah.
Very cool. Thank you very much. I think that's it. That's it for all the question. Yeah, that's all the question. So thank you very much, James, for this one, for showcasing everything that's been released. Thank you everyone for coming. Have a good morning, afternoon, or evening, depending on where you are in the world. Feel free to join our Discord as well if you have some questions. And I'll see you during our next one. Thank you. Bye.